Hey everyone, welcome to Homework 1.17. Today we are doing a review because tomorrow you have your quiz. So I'm going to go through each of the problems with a little bit of review for each one. And then if you have any questions, you know how to reach me. So select all equations that are equivalent to 2x minus 5 all over 3 equals 4 minus 5x minus 2. So the first thing that I do when I look at this is I think, well, how can I simplify this side? And so I'm going to go ahead and do that because that'll give me one thing that I know I'm looking for. So when we have a 4 minus, this is subtracting 4 minus 5x minus 2. And so this minus is outside of the parentheses, which means we need to distribute. So this becomes 4 minus 5x, and then a negative times negative 2 is plus 2. Therefore, our new answer is 2x minus 5 over 3 equals 4 plus 2 is 6, so negative 5x plus 6. So you know that's one thing that I'm looking for as I look at this. Let's take a look at the answer options. Notice also that it says select all. Generally speaking, when it says select all, there's going to be 2 to 3 answers. Not always, but there's almost always more than one. So we have 2x minus 5 equals 4 minus 5x plus 2. In this case, all they did is they removed the 3 from the denominator, but that's not something that we can do unless we were to somehow do something to the other side. So since the other side is still exactly the same, we know that this cannot be because they would no longer be equal. Letter B has actually what I came up with over here. So 2x minus 5 over 3 equals negative 5x plus 6. So that we know is an answer option. Letter C is the same as the original equation, except they broke it up into two fractions. So this is perfectly legal because this and this are separate, can be separated as long as you keep your signs correct. So if we were to have, as another example, 3x minus 1 over 2, this is the same as 3 over 2x minus 1/2. Okay, you can split that equation so that each part is dividing by 2 or creating a fraction with 2. Letter D has a very similar piece. In fact, it is exactly the same. So letter D is identical to this, which means that it is in fact equivalent. Letter E has very similar to what we had here, except plus 2. So that we know is not correct because that's not equivalent to plus 6. If we were to have chosen that, then we would have not distributed our negative sign. So the reason that someone might have accidentally chosen this one is if they did 4 minus 5x minus 2. If they didn't distribute this negative sign and they just put 4 minus 5x minus 2, they would get negative 5x minus 2, or plus 2 instead of plus 2, which would then make it 6. So this would be this one would be a common mistake if you didn't distribute your negative sign. So be very careful with that negative sign outside of the parentheses. And lastly, letter F says 2x minus 5 equals negative 15x plus 18. So this is similar to the first one, except it looks like they did in fact do something to this right side. So we discovered that the right side was also equal to negative 5x plus 6, and it looks like what they did is they multiplied the whole thing by 3. And so when they did that, right, the 3 over 3 canceled out. They didn't multiply this one by 3, sorry, that looks confusing. The 3 cancels out, and so you're left with 2x minus 5 on this side, and then you multiply 3 here, we get equals 12 minus 3 times 5x minus 2, and so we end up with 2x minus 5, sorry, I wrote the equal sign twice, equals 12 minus 15x plus 6. It's a negative times a negative. And so that gives us negative 15x plus 18. So this one is also equivalent. And again, what they did is they multiplied the entire thing by 3 to get that 3 out of the denominator. All right. Number 2. A taxi company charges a flat $2 fee and then is an additional charge per mile and can be represented with this equation, where C is the charge per mile and M is the number of miles. which equation can be used to find the number of miles? So we're looking for m equals. So if we have t equals 2 plus c times m, and we want to find m, we first are going to get rid of this by subtracting 2 on both sides. So we get t minus 2 equals cm. And then I want m by itself, and this is multiplication, so I'm going to divide by c. So the best answer is letter A, which matches that. Letter B, they just subtracted c, which we cannot do because it's being multiplied by m. Letter C, they inverted this, so that's not correct. And letter D, they divided before subtracting, and you cannot do that. So in this situation, you have to subtract this first, right? Move the thing that's the furthest away from it, subtract 2 on both sides first, and then you can do your division. So you have to do it in that order. All right. Number 3. Tickets to the movie theater cost $15 per adult and $16 per child. Miss Lee is throwing a birthday party and has a budget of $300 for the movie viewing party. An equation, so it gives us the equation, is graphed below. Now notice here they've done 15x, and we know it's 15 per adult. So that means x equals adults, and y equals, not students, but kids, or children, right? So I'm going to mark on my axes, sorry, I don't know, my pen's doing all kinds of things, that x is adult tickets and y is child tickets. Okay? And so that'll help you when you're analyzing this. So first figure out what do your variables stand for, and then label your graph, because that'll help you to interpret the graph. So if no children go, that would be 0 children. 20 adults can go. That is true. That is on our graph. If no adults go, so if this was 0, 20 children can go. That is not true. We do not have the line crossing there. If no, there's a typo here, sorry. If no adults go, 50 children can go. So if no adults, we're at 0 adults, and then we go up to 50, we do have our line crossing that point. So that is true. If 25 adults go, so let's go over to 25 adults and go up to 10 children, that is not on the line, so that is not true. If 10 adults go, so here, and then we go up to 25, that is true, because it's on the line. If 2 more adults go, there will be space for 5 less children. Well, there's a couple ways that I can think through this. If 2 adults go, that's $30, right? And for $30, if the tickets are $6 per child, I can take 5 kids. So if 2 more adults go, then there's 5 less children. That does make sense, because the more adults go, then the less children can go. You can also look at this in terms of the graph, right? If we look at the graph and see that every time we move over 2 adults, are we going up 5 children? And the answer is yes, right? So every time, if I were to look at this point here, let's make this a different color, make it a little stand out a little. If I look at this point here, if I go over 2 and up 5, right, I'm going over 2 adults, up 5 children. So as I increase 2 adults, I have to decrease 5 children. All right, number 4. A 20-centimeter necklace can have links and charms added and cost $50. Each additional centimeter is $2, and each additional charm is $5.50. Write an equation to represent the total cost of the necklace. So, in this question, I'm not solving anything. I'm just writing an equation. And it's representing the total cost. So in looking at this, I don't know what the total cost is. So I'm going to use T. And I'm going to say down below, T equals total cost. Because notice it says make sure to specify what the variables represent. So you need to tell me what each variable stands for. So T equals total cost, and I don't know what that is, so I'm representing it with T. The initial cost of the necklace is $50. So I have $50. I know that's part of my cost. And then every time I add a centimeter, it's $2. So that's going to be plus 2C, because I'm going to multiply $2 times every centimeter that I add, right? And then it says, oh, what are all these ads? Goodness gracious. All right. Then it says that each additional charm is $5.50. So I'm going to add another $5.50 per charm. Let's go ahead and we'll represent charm with T. doesn't matter. You can choose any letter. The important part is down underneath you, they say that C equals centimeters added and T equals charms. All right, so you can represent, you can choose any. I saw other people said that they said, well, they wrote it as X equals the centimeters and Y equals the additional charms. And so then you would write this equation as 2x plus 5.5y. Okay, so any variables, you can pick any variable you want. This is it. That's it. That's all you're doing is writing the equation for the situation. So you can pick any variable that you like. You just need to make sure that you tell me what the variable means and what it stands for. All right, number 5 says consider the system of equations, solve by graphing, label each graph and the solution. So I'm going to go ahead and I'm going to draw a graph. It's not going to be super pretty, but we're going to do the best that we can. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and then all right, so we're very lucky in that this first equation is in slope-intercept form. So I have a y-intercept of 2, and then my slope of negative 1/3. So it's going down by 1 and then over 3. So down 1 and then over 1, 2, 3. Down 1 and then over 1, 2, 3. Down 1 and then over 1, 2, 3. Okay? And so now I have a nice little line that I can draw. And I'm going to do my best to draw the straightest possible line here. Nope, 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 nope. Oh no, terrible things are happening. Okay. Let's try to get this back. Okay, there we go. Whew, sorry about that. All right, that didn't go as planned. So I'm just drawing the best possible line, and it's going to be kind of bad, but there you go. All right, so that's our first line. Our second line, we have 2 ways we can do this. One, I can put this in slope-intercept form. So let's do that. If I put this in slope-intercept form, I'm going to subtract 2x from both sides, because remember, slope-intercept form is y equals mx plus b. So I need to solve for y right here. So I'm going to subtract 2x to get rid of that, and I will end up with negative 3y equals negative 2x plus 24. Then I divide both sides by negative 3, and I'll get y equals 2 over 3x minus 8, right? A negative by a negative becomes a positive by a negative is a negative. So now my y-intercept here is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's a positive slope going up 2 over 3. So up 2 over 3. Up 2 over 3. Up 2 over 3. All right, and so you're going to then look for where is my line going to intersect. It would be there. Okay, it's not very well drawn. On your actual quiz, it's online, and so when you plot your 2 points, as soon as you plot any 2 points, you can draw a line with those 2 points and look for the intersection, and then we note that that's our intersection, so that means that that's the solution, right? The other way that you can graph is you can do your y-intercept and your slope, but you can also find your x and y-intercepts. And if you find those, then you'll be able to plot 2 points. So when I find my x and y-intercepts, I'm solving where x is 0 and where y is 0. So when x is 0, we get negative 3y equals 24. That gives us negative 8. We saw that here. That's our y-intercept. If we are saying that y equals 0, then we get 2x equals 24. And so then x equals 12. So then our x-intercept is over here. And let me change the color there a little so you can see. That's not a very good change. Nope. I don't know if you're going to see that. There we go. Here we go. Green is over here at the 12 mark. And so then you would have these 2 points, and you could draw a line between those two. All right. So on the computer, when you see that quiz question, all you need to do is plot 2 points. And once you plot 2 points, then it will create the line, and you can look for the point that intersects. All right. Number 6 says solve without graphing. So I'm going to actually show you 2 ways to do this. And if you have a particular way you want to do it, you can move ahead to the part that you want to do, however you prefer. But solve without graphing. So two ways that we can do this. I'm going to put it over here. 2y equals x plus 2 and 2x minus 3y equals 12. So the one way that I can do it is I can do substitution. And I'm looking for the easiest thing to solve for, which is x. So if I do that, nope, I touched something, did bad things. I'm having a lot of technical difficulties today, guys. This is just, oh, okay, nope. Don't want you, keyboard. Okay. Here we go. All right. If I want to solve for x, I'm going to get 2y equals x plus 2. I'm going to subtract 2 from both sides. So then we get x equals 2y minus 2. This whole thing can now go in place of the x in the other equation. So that would be 2 times 2y minus 2, right? I replace this x, minus 3y equals 12. Now my first step is going to be to distribute. So I'm going to get 4y minus 4 minus 3y equals 12. And then 4y minus 3y, because I'm going to combine my like terms here. I'm going to combine this with this. 4y minus 3y is going to leave me with just y minus 4 equals 12. And now I can add 4 to both sides, and I will get y equals 16. So that's part of my answer. And then I want to solve for x. So if I plug in, and then this is actually where a lot of you are making mistakes because you're not writing it out. You're trying to do it in your head, which I love and appreciate your mental math, but I need you to write these things out. So 2 times 16 equals x plus 2. 2 times 16 is 32 equals x plus 2. Subtract 2 on both sides, and therefore x equals 30. Now you have a solution. So that's the one way to do it, through substitution. Okay? The other way that we can do this is through elimination. So I have 2y equals x plus 2. And in order to do elimination, I need my x to be on the other side. So I'm going to subtract x from both sides. And then I'm going to rewrite this as negative x plus 2y equals 2. Then I can write underneath 2x minus 3y equals 12. And now it's apparent to me that if I multiply my top equation by 2, I'll get something I can cancel out. So this becomes negative 2x. 2 times positive 2y becomes plus 4y equals 4. These will cancel out, and I'll be left with y equals 16. So notice I got the same answer, I just did it a different way. So you can choose to do substitution, or you can choose to do elimination. The key thing that I want to point out with elimination is that you need to line up your x's and your y's. So x and y need to both be on the same side with equals and then a number on the other side. All right, otherwise you can't just eliminate. I thought that was the eraser, there we go. You can't just eliminate that way, okay? You have to have them lined up so that you can see that. But you can choose which way you prefer. All right, number 7 says this system of equations has exactly one solution. If we triple the first equation, we have 6y plus 3x equals 6. So let's take a look at that. If we do 2y plus x equals 2, and we multiply it by 3, tripling it, we get 6y plus 3x equals 6. That is correct. All right, but what this is asking you is why is this equation... Okay, sorry about that. So what this question is asking is explain why the same pair is the solution to this equation as it is to these two equations here. So the reason is, so in this explanation, you can either use a hanger diagram or you can give me a situation, all right? So I'm going to do both. If we have a hanger diagram and we represent our y, say for example, with a circle, and there's 2 of them, and we represent our x with a square, and there's 1 of them, and then we represent this 2 with, we'll say, since it's the number 2, we'll represent it with a giant circle with 2 in it, okay? If we triple that, Then we have now 6 circles, 1, 2, 3, 4, 5, 6, and triple the x's, so 3 squares. And then we're also going to triple this. And so our numbers remain balanced. So if as long as we triple both sides, we maintain a balanced equation, and therefore they will have the same xy pair as a solution. The other way that you can explain it is through an example. So the example I talked about at lunchtime today with some of you is that imagine that this represents a situation. So if Miss Lee buys 2 bananas and 1 apple, it costs $2. Now, if I were to buy 3 times as much, if she buys 3 times as many, she'll have 6 bananas and 3 apples for $6. But notice the X and Y amount, right? The amount that each banana costs and the amount that each apple costs will remain the same. So even if she buys 3 times the bananas and 3 times the apples for $6, the unit rate of bananas and apples stays the same. And so therefore the solution stays the same. In the example we did in class, we had the teacher who bought, 2 calculators, and we can use the same example, 2 calculators for a certain cost. So let's say 2 calculators plus 1 tape measure, 1x, and let's say that equals $2. If I buy 3 times as many, right, then we'll have 6 and 3 equals now $6. The value for x and y that will work for both of them will still be the same. So those are 2 ways that you can do it. You can either prove it by explaining it as a situation, or you can prove it by showing me the hanger diagrams. All right, for this last one, it says, if we add the 2 equations together, we get 3x minus y equals 14. Explain why the same xy pair is also a solution to this equation. So the easiest way to explain this is if we were to graph the first 2 equations, they would intersect. This is not necessarily the graph, but this is an example, okay? If we were to graph these 2 equations, they would intersect at a point, and that would be the solution. If we graph the resulting equation, then we will get another line that intersects and therefore has the same solution. All right, so a new equation created from adding equal sides to equal sides will create a new equation that intersects the original 2 lines or the original 2 equations on the graph. All right, and remember, as long as you add, and you can also say this in words, as long as you add equal sides to their respective equal side, you will get the same solution. So again, you can explain it to me that way. You can also, again, create a hanger diagram. That would be fine as well if you want to create the 2 equations added together and then create a diagram to represent them like we saw in the example on the other day when we were learning why these remain the same. That would be fine as well. So a similar hanger diagram as these up above that shows me that would be fine. Or you can just explain, as long as you add equal sides to their respective equal side, you will create an equation that gets the same solution. Okay? All right, that is it for your main homework. And make sure that you review and study and practice. Be really careful with those signs, because that seems to be one of our areas that we need to stay super diligent about. And then the rest of this, if you do it, is review for how to use your calculator to graph systems of equations, which is going to be very important for the next part, and then also thinking about how we know how many solutions there will be. This last piece right here is just practice adding positive and negative integers. So if that's something that you still feel like you're not super strong with, practice it in your head, practice it on paper, and then check your answers with the calculator and make sure that you're doing it correctly. Okay? All right. Your code word for today will be popcorn. Your code word for today is popcorn. And if you have any questions, please reach out and I will see you tomorrow. Happy homeworking.